My dear students, today I would like to discuss about relative velocity of boat and river by using flow chart. Okay, so now you can just see here the first diagram will represent the shortest path here. Okay, this is going to represent the shortest path. What is the meaning of shortest path? A man who is on this side of the river of the bank, which can be taken as A, is trying to reach the exactly opposite end, that is B. If he is trying to go to the opposite end B, then what should be his aim? His aim should be along with C, so that the river which is flowing in this direction will drift him and take him to B. So if you want to reach in a shortest possible path exactly across the river, he has to tilt his boat little bit certain angle with the vertical, so that the river will take him exactly to B. So if he aims at C, he will reach at B. That is the main concept here. And he has to make certain angle theta with the vertical so that he can reach exactly to B. So this is going to be the velocity of the boat. This is going to be the velocity of the river. And in this direction, it is going to be the resultant velocity. Okay. So our aim is to find out the resultant velocity now in a shortest possible path. So if you apply Pythagoras theorem here, you know that AC square is equal to AB square plus BC square. So what is AC here? AC is nothing but velocity of the boat, pure velocity of the boat, and AB is nothing but resultant velocity whole square plus it is the velocity of the river whole square. Therefore, resultant velocity is going to be velocity of the boat whole square minus velocity of the river whole square. So therefore, resultant velocity is equal to square root of VB square minus VR square. So we got the resultant velocity. Next, we have to find out the resultant velocity in the case of shortest time. So now, man on this side of the bank, he is at A. His aim is to reach exactly in a shortest possible time. Okay. So then what he has to do? His boat has to aim exactly towards B, but the river which is flowing in this direction will take him to C. Okay. Now, so what is an actual path followed by the boat? It is AC. Okay, so it is making certain angle. This is going to be the resultant velocity. Now the resultant velocity is going to be the hypotenuse. Therefore, here also you are going to apply the Pythagoras theorem. Here also we write AC square is equal to AB square plus BC square, whereas AC square is nothing but V resultant whole square, resultant velocity, and AB is nothing but velocity of the boat whole square plus velocity of the river whole square. Therefore, we can take resultant velocity is equal to square root of VB square plus VR square. If you just see the difference for shortest time and shortest path, in shortest path, velocity of the boat whole square minus velocity of the river, minus is coming here. Whereas in the case of shortest time, you are getting velocity of the boat whole square plus velocity of the river whole square under root. Okay. So now we got the resultant velocity. We have to find out the direction now. So how are you going to find out the direction in the case of shortest path? So direction is nothing but angle theta. So to find out angle theta, you already know that velocity of the river, you know velocity of the river, you know velocity of the boat. In the case of shortest path, as you know the river velocity, as you know your boat velocity, you have to consider opposite side by hypotenuse. These two velocities, as you know, it is better to take sine theta, because opposite side and hypotenuse is related to sine theta in trigonometry. So we can write sine theta is equal to opposite side, that is VR, by hypotenuse is nothing but VB. Therefore, we can find out an angle theta, that is theta is equal to sine inverse of VR by VB. We got angle theta. So in the case of shortest time, how can you find out angle theta? So here also you have to find out direction, that is going to be theta. So here in this case, we know the velocity of the river, we know the velocity of the boat in the case of shortest time. If you see the diagram of shortest time here, that is this diagram, shortest time. So in this diagram, if you observe, we know opposite side, that is we know river velocity, I know my boat velocity, that is taken as VB. Opposite side I know, adjacent side I know. That means I can apply tan theta. Okay, so I can write now tan theta is equal to VR by VB. Okay, so this implies that theta is equal to tan inverse of VR by VB. Okay, we got the direction of the boat with which it is tilted because of river flow. Next, the last thing is we have to find out the time along the shortest path and time along the shortest time. So time, you all know, velocity is equal to distance by time. Time is equal to distance by velocity. So in the case of time, for shortest path, it is nothing but distance. What is the distance here? Distance is taken as AB. Okay, AB is going to be the distance and the velocity is going to be the resultant velocity, that is V resultant. Therefore, we can consider AB, which is said to be the width of the river, and resultant velocity is going to be square root of VB square minus VR square. Now we have to find out the time along the shortest time. So you all know here also velocity is equal to distance by time. This implies that time is equal to distance by velocity. So time along the shortest time is considered as distance. Here distance is nothing but AC along the with the actual path of the boat is taking place. Actually, AC is the direction with which the boat is traveling now. It may take distance a little bit longer, but as the river is supporting the boat to reach the opposite end, it will reach in a shortest possible time. Maybe path is hypotenuse, but time will be less. So time is going to be distance by velocity, where distance is taken as AC and velocity is taken as resultant velocity. Okay, so that is AC by V resultant, so which is nothing but VB square minus VR square. So in this way we can find out the direction, we can find out the resultant velocity, we can find out the time also. So if you compare the shortest path and shortest time, both the times here you can take here plus, no, yes, in shortest time in velocity VB square plus VR square you'll get, whereas here VB square minus VR square you'll get. Here denominator is less in the case of shortest path, so fraction is more, time is more, whereas in the shortest time denominator is added VB square plus VR square under root. That's why denominator is more, fraction will become less, so time along the shortest time is very less compared to shortest path. So this is a simple concept of shortest path and shortest time. Hope you have understood that.